Welcome back, everybody. I hope everybody's fine and ready to learn about quadratic relations more. Quadratic relations in general have three forms. The first form is called the vertex form, which we have already learned. It's in the form of y equals a times x minus h squared plus k. And in this form, we know that the vertex of the parabola is located at h comma k. So from the equation, we can easily find out what the coordinates of the vertex are. The value of a is the stretch or shrink factor, and we know if it's positive, parabola opens upwards, we have a minimum point. If it's negative, the parabola opens downwards, we have a maximum point. But generally speaking, that a is never equal to 0, because if it is 0, then we don't have a quadratic relation to begin with. So that's the coordinates of the vertex. Equation of the axis symmetry is, needless to say, it's x equals h, as we have all learned in the past, and also the optimal value, which is either max value or mean value, is equal to the k, the y coordinate of the vertex. We have learned about this in the past, and we know that if a is positive, greater than 0, parabola opens up, of course, and that means we have a minimum point. The vertex is a minimum, and if a is less than 0, that is negative, then the parabola opens down, which means we have a maximum point and the vertex is maximum. So these are the brief properties of the vertex form, and you can learn about all of these properties by just looking at the equation of the vertex form. That's how useful it is to have the equation of a quadratic relation in vertex form. But sometimes we have a quadratic relation in standard form. So we may say, what is the vertex? Well, it's hard to find the vertex right now. So that's the disadvantage of having a quadratic relation in standard form, because you can't just quickly tell what the coordinates of the vertex are, whereas in this case you could in vertex form. But the advantage of standard form, if you want to learn, is that the c value, the number that you see there, let's say 5, 2, whatever it is, that is the y-intercept. So you can quickly, without touching a pencil, you can say that the y-intercept is equal to c value, actually. But just looking at the equation, you can tell. But in the vertex form, if I say, what is the y-intercept, you will know, because you have to set x equal to 0. You have to do some calculation, perhaps using your calculator. It will be ah squared plus k. That would be the y-intercept. So you have to do some work. But in standard form, the advantage is that by just looking without touching a pencil, you can tell that the c value is the y-intercept. So we see that each form has its own advantages, end of the day. Now, believe it or not, there is a third form to a quadratic relation. It's called intercept form or factors form. This form is in this form: y equals a times x minus r times x minus s. Right now, probably you are scratching your head thinking what stands for r, what stands for s. Well, r and s are the x-intercepts of the parabola, or we call them zeros of the relation. So r and s, so I put r and s, I go x-intercepts, okay? Or we call them zeros of the relation. X-intercepts of the parabola or the graph. In other words, zeros of the relation. That's what R and S stand for. A is the same old as we had in the past, and we know that A can never be positive, can never be 0, and same thing here. And if it's positive or negative, we talked about it before. Now, let's say we have a quadratic relation whose equation is y equals 3 times x minus 2 times x plus 10, okay? This is a quadratic relation in factored form or intercept form. Now, by looking at the equation, the advantage of this form, intercept form, is that by looking at the equation, you can tell where the x-intercepts of the parabola are. That's the advantage. You can't tell where the vertex is right away, just used to do in vertex form, but you can tell what the x-intercepts are. So here I would say r is equal to 2. What stands for r in the formula is 2. And what stands for s is actually negative 10. Because The formula says x minus s. I don't have x minus 10. I have x minus minus 10, which is x plus 10. So that means that what stands for s is not positive 10, but instead it is negative 10. You have to be careful about this. So r is positive 2, but I have x minus 2 there. S is negative 10, but I have x plus 10, because the formula is always in the form of x minus r times x minus s, where r and s are the x-intercepts. So if I just want to quickly plot this parabola, I know that it's going to be opening upwards because the value of a is 3, and that is positive. So let's say if this point here is the x-intercept 2, and the other x-intercept is, let's say, at negative 10, so it would be some sort of parabola, which would look like something like this. If I sketch it, this is not an accurate graph, but it's just a sketch, a parabola opening upwards, and the two x-intercepts are 2 and negative 10. All right. Now, what is the y-intercept? Well, if I want to find the y-intercept right here, I wish actually the equation was given in standard form, because I could quickly look at the c value and quickly find out what the y-intercept is. But right now, if I want to calculate this y-intercept, given the equation in factored form, I have to set x equal to 0. So that's the procedure of finding the y-intercept. You always set x equal to 0. We know that from before. So if I set x0 here is x0 there, I end up with y equals 3 times 0 minus 2 times 0 plus 10, and that would be negative 60. So that means that this y-intercept of the parabola is somewhere at negative 60. That's the point where the parabola intersects the y-axis. But then another thing I want to share with you, another property, good positive property of factored form or intercept form of a quadratic relation, and that is when you have your vertex and you have your axis of symmetry, which cuts the parabola in half, okay, it is needless to say, due to the absolute symmetry involved in any kind of parabola, we know that the axis of symmetry is exactly in between, midway between the two x-intercepts. So the question is, how can I find the midway exactly in the middle between the two values of 2 and negative 10? Well, how do you find the average of two numbers? That's exactly the value, the middle value between the two numbers, right? So I'm going to add 2 with negative 10, which would be negative 8, and I divide it by 2 to find the average. How do you find the average of two numbers? Add them up divided by 2. I do the same thing here. I add 2 with negative 10, that's negative 8. Divided by 2, negative 4. So I know exactly that the equation of axis of symmetry should be x equals negative 4, and I know that the vertex must be happening at x equals negative 4. That's the x-coordinate of the vertex, okay? The way you find the y-coordinate of the vertex is by substituting back negative 4 in the equation, and then you can calculate the y-coordinate of the vertex, of course. So I can do that, for example, if you want me to find y-coordinate of the vertex, I go 3 times negative 4 minus 2 times negative 4, and then plus 10. I substitute negative 4 for x in the equation. So that gives me 3 times negative 6, and that is positive 6. So that will be negative 3 times 36. You do the math using a calculator, that's going to be 108, negative 108. So this is the y-coordinate of the vertex right here. So I can tell that the vertex is located at negative 4, comma, negative 108. That's the coordinates of the vertex. So the equation of the parabola was given in factored form or intercept form, but I could calculate everything else I needed, including the coordinates of the vertex, including the equation of axis symmetry, and from the equation, I could easily tell what the x-intercepts of the parabola are. One last thing I want to show you, and that is some sort of formula that we can come up with this idea of axis symmetry or the vertex being exactly midway between the two x-intercepts. I can say that the x-coordinate of the vertex is always r plus s divided by 2. This is that idea of average we talked about, okay? But I just wanted to give it to you as a formula. So x coordinate of the vertex, which we called it h in vertex form in the past, is equal to r plus s divided by 2, or the average of the x-intercepts. R here is 2, s is negative 10, add them up, negative 8 divided by 2, negative 4. So that means that the x-coordinate of the vertex is at negative 4, as we said before. Okay, so that's another important property to remember. Wrapping up, we have 3 forms for quadratic relations: vertex form, intercept form, standard form. And each form has its own pros and cons. Advantages of having the equation vertex form is that you can tell what the coordinates of the vertex are, or equation of axis symmetry, optimal value without touching a pencil. You can look at the equation and identify all these properties. Advantage of the intercept form is that without touching a pencil, by only looking at the equation, you can easily tell what the x-intercepts of the parabola, that is the zeros of the quadratic relation, are. And the advantage of a standard form is that you can tell what the y-intercept is by just looking at the equation without doing any kind of calculation. All right? So I think this much would be fine for now, and then I'm going to give more lectures for this unit later on. Thank you.